Once again, good afternoon and welcome to our Mathematics of Investment class. Last meeting, we have talked about simple ordinary annuity. It's simple because the compound interest, the compounding period is the same as the payment interval. And it's an ordinary annuity because the payment is done at the end of the period. We have solved for the future value, present value, and also for the periodic payment. And this afternoon, we're going to solve for the term of the annuity and also for the interest rate. Now you can take a screenshot of this. This is our formula for the simple ordinary annuity once we are looking for the time. Remember, the time is a part of n, since n is compounding period times the number of years. So this is derived from the main formula. The S sub n equals r times I plus 1 to the n power minus 1 all over I. Now let's have the first problem. Here's the first problem. How long will it take for an annual year-end contribution of 57,000 to an educational savings plan to grow to 1 million if the educational savings plan earns 13% compounded annually? Now we need to identify first the given. Now what is 57,000?
Present value.
Not the present value. It's an annual year contribution. What's 57,000? It is periodic payment, the regular payment. So we name it R. And we want it to grow to 1 million. What is that 1 million?
Future value.
Very good. It's our future value. So it's our S sub n. Now what is 13%?
J.
J, our nominal interest. And compounded annually. So what is our M?
1.
1. Very good. Now, since we have our J, we can also compute for our I. What is the value of our periodic interest rate?
0.13.
Very good. 0.13. Because that is 0.13 divided by 1. Now, we're looking for this one. How long will it take? So basically, we're looking for T. But we did not solve for T right away. Instead, we need to solve for N first. So let's have the N. Here's the formula. N equals log Sn times I over R plus 1 over log of 1 plus I. Let's solve. Let's first substitute. That will be log 1 million times I. 0.13 over R, 57,000 plus 1 over log I 1 plus 0.13. Now let's use our calculator. That will be log on top and another fraction. Log of 1 million times 0.13 over 57,000 plus 1 over log 1 plus 0.13 here. if you will see, the value of our n is 9.72. Let me first write it. The value of our n is 9.72 years. Remember that n is m times t, right? But our m is 1. So it means that you don't need to divide it. But if there is a value, a different value for m, you need to divide first your n before you can have your t. So for this problem, our n is 9.72 years. Ma'am, what if it's not compounded annually? What if it's compounded semi-annually? Then it's going to be n equals 2t. So you need to divide your n to 2 to get the answer for t. Any questions?
Yun sa bagwa ang 9.72, ma'am.
This one, right? Let me show you the calculator here. Can you see it? I just encoded it all. That's log 1 million times 0.13 over 57,000 plus 1 over log times 1 plus 0.13. Any questions?
No, ma'am.
It, Vince, where did we get it? That's why you could have your 4-line calculator. The problem is if your calculator is 2-lined, so solve for the numerator first, then divide it by the denominator. Now let's go to the next problem. Winston and Reina are discussing the terms of a 270,000 home improvement loan with their bank's lending officer. The interest rate of the loan will be 18% compounded quarterly. How long will it take to repay the loan if the quarterly payments are 25,000? Now, what is this 270,000? What is
Present value.
very good? It's the present value because it is the amount Winston and Reina will be borrowing. So A sub n. The interest rate is 18%. What is that? What's the 18%?
G, ma'am.
RJ.
Our J, our nominal interest, compounded quarterly. So what's our M?
4.
4, very good. And what's 25,000?
R. Our R.
Very good.
Periodic.
For the how long again, okay? We're looking for the number of years. Now let us first have it. Let's have N equals the formula with the A, okay? 1 minus A sub N times I over R. All over negative log of 1 plus I. Now let us start substituting. That's log 1, minus 270,000 times our I. Oops. What is our I, by the way? What is our I?
0.045.
Very good. 0.045. That's 0.18 divided by 4. So times 0.045 all over 25,000 over negative log times 1 plus I. Okay, from there, we need to encode that all in our calculator. So 2 fractions, log on top, then 1 minus another fraction, 270,000 times 0.045 over 25,000. Close parenthesis. Over, that's another log, sorry, negative. Negative log times 1 plus 0.045. There. You see the answer? That's 15.12. But you need to go back to the compounding period. 15.12. The compounding period is quarter by quarter. So it means that our N means there will be 15.12 quarterly payments. So our N is 15.12 quarters. But if the question is how long, this can be the answer, 15.12 quarters. But if the question will be how many years, then we need to divide it by 12. Again, it depends on the question. So we divide the answer, the answer, clear. The answer we divide, not that one. 15.12 we divide by 4. Then in years, it will be 3.78 years. Both answers are correct. It depends on the choices. Any questions? No other.
No, ma'am.
So I assume you've understood it well. Let's go to the next type of problem. Now this time, let's have for the interest rate. How are we going to solve for the interest rate? Now this looks like a complicated derivation of the formula, but here's what we will do. The main formula is this, the main derivation. We're looking for I, okay? If you notice, we have the factors are I squared, I, and the one without an I. That I squared plus I plus the constant equals 0. This is what we call the quadratic equation, the general form. Now, since this is the general form of the quadratic equation, then how can we solve for I? Let's use the quadratic formula. So in the quadratic formula, we have this one, I is equal to negative b plus and minus b squared minus 4ac over 2a. But you might ask, there's no a, b, c in the formula. But since we have I squared, I and the constant, then the first one will be a, n squared minus 1. The second will be b, the 6 times n plus 1. And the third, this one will be c. Same is true with the other one. N squared minus 1 is our a. Our b is negative 6, quantity n minus 1. And our c will be 12 times 1 minus n times r over s sub n. Now let's start with the problem. A loan of 8,838.51 is to be discharged by making 15 semi-annual payments of 940 each. At what rate, compounded semi-annually, is the interest charged on the loan? Now, what is 8,838.51? What is that?
Present value.
Very good. It's our present value, our A sub n. 15 semi-annual payments. What is 15 here?
Or N man yan.
Good, Rn. No longer T, no longer R. Because remember, N is asking us how many payments will there be. So 15 is Rn. Next, how about 940? What is that? $940.
R.
Very good. That's our R. And it's compounded semi-annually. So what will be our M? What is our M? Our M is 2. Very good. Since the given is the present value or A sub n, so we use the formula. I'll go back to the previous slide. I'll use the formula with this one, the first one, with A sub n, because that's the one being given. Now, we have the formula is n squared minus 1 squared times I squared, plus 6 quantity n minus 1 plus 1 I plus 12 times 1 minus nr over A sub n equals 0. We can start computing for our A, B, and C. So let's start computing for our A. N squared minus 1, that's going to be 15 squared minus 1. That's 225 minus 1. So our A is 224. Next, let's compute for the B, this one. That's 6 times n plus 1. So 6 times 15 plus 1, that's 6 times 16. The answer is 96. Then our C, 12 times 1 minus NR. Our N is 15. Our R is 940 over A sub N, 8,838.51. Let's use our calculator first. That's going to be clear. 12 times 1 minus 15 times 940 over 8,838.51. If you check, the answer will be negative 7.1434. Actually, they copied this all. Let's also copy that to get the exact answer. Negative 7.143498169 in the book. It ended with that. So once you have your ABC, let's solve for the quadratic using the quadratic formula. The I is equal to negative B plus and minus square root of B squared minus 4AC over 2A. It's negative 96 plus and minus 96 squared minus 4 times A, 224, times C, negative 7.14. Sumpayin na lang ninyo. All over 2 times A. Okay, here. Let's solve. In our calculator, negative, we clear that. Negative 96, that's a plus and minus. We can have the plus first. Plus square root of 96 squared minus 4AC, negative 7 point, type all, 498169 all over 2A here. Our first answer is the first answer for I, sorry. The first answer for I is 0.0647, or that is 6.47%. Now let's try. What if, because it's plus and minus, right? What if it's minus here? Let's change it. The answer will be negative, and there's no negative interest rate. Therefore, the second possible answer is not okay. So with that one, our final answer will be 6.47%. Again, to review, you need to solve for A, B, C first. And once you have the values of A, B, and C, you can use now the quadratic formula in solving for the interest rate. Any questions? It's a long process, right?
Taas di kayo makalibog, ma'am.
Yes.
Pwede mong kuan, ma'am. Diyon sa ganyan napagkuha ng sa A, ma'am.
Here.
Libog.
This is the formula, Vince, the whole formula, right? So if this is the formula, the one that goes with the I squared, the n squared minus 1, will be your A. You just substitute the n. For B, the one that goes with I, so 6 times n plus 1. For C, the last term, so this whole thing will be your C. Other questions? No other questions? We'll have a parallel problem.
Muna ning final, ma'am, 6.47%.
6.47%. That's the final. Okay, let's have the other problem, the last one. This time I will let you solve for the ABC. Payments of 300 pesos each is made every year. What is that 300 pesos?
R.
R, very good.
R.
At what rate? We're asking what rate? Compounded monthly. So what will be our M?
12, ma'am.
12. Will these payments amount to 8,336.42? What is that?
Future value.
Very good. Future value. The keyword will, amount to. So future tense. In 2 years. What's our T?
2.
2. So what will be our N? What's our N?
24.
24.
Very good. 24. Now, we are looking for the interest rate, and the given is the future value. So we'll be using the other formula. The other formula is n squared minus 1 I squared minus 6 times n minus 1 I plus 12 times 1 minus nr over s sub n equals 0. This will be our, maybe you're confused because of the I. You know what the I? You just cancel those all I. And you just look at what's remaining. This is A, B, and C. Now I'll give you the time. What will be our A? What's the value of our A?
575.
Very good. That's n squared minus 1. So our n is 24. You square it minus 1. The answer is 575. Next, what will be our b? What's our b?
Negative 138.
Okay, very good. That's negative 6. This one is our b, right? Let me change my pen color. This one is our b. So negative 6 times n minus 1. That's negative 6 times 24 minus 1. That's negative 138. Now, how about our C? What's the answer for our C? This one is our C. Sorry, I forgot to record a while ago.